Taking to the skies, helicopters are fascinating machines. They defy gravity with their unique design and engineering, allowing them to hover, ascend, and maneuver in ways that fixed-wing aircraft simply cannot. Unlike airplanes, they generate lift and control from spinning rotor blades. These blades are the heart of the helicopter, constantly in motion to keep the aircraft aloft. These blades act like rotating wings, slicing through the air to produce the upward force we call lift. The faster they spin, the more lift they generate, allowing the helicopter to rise into the sky. But lift is only half the story. To truly master the skies, helicopters need more than just lift, they require precise control. Helicopters also need precise control to maneuver through the air. This control allows them to perform complex maneuvers, change direction swiftly, and hover in place with remarkable stability. Imagine a helicopter trying to fly without a way to control its direction or stability. It would be a chaotic and dangerous situation. It would be like a leaf caught in a whirlwind, tossed around uncontrollably. Without control, the helicopter would be at the mercy of the elements. That's where control systems come in. These systems are crucial for managing the helicopter's flight path and ensuring it responds accurately to the pilot's commands. Control in a helicopter is all about managing the forces acting on the rotor blades. Pilots must constantly adjust these forces to maintain stable flight. By subtly changing the pitch or angle of these blades, pilots can tilt the rotor disc, directing the lift force to achieve different maneuvers. This allows for precise control over the helicopter's movement. This intricate dance of lift and control is what allows helicopters to perform their unique aerial feats. It's a testament to the skill of the pilots and the advanced engineering of these incredible machines. Flying high above the ground, safety is paramount in a helicopter. One crucial component ensuring this safety is the freewheeling unit. It acts like a safety net, allowing the helicopter to land safely even if the engine fails. Think of riding a bicycle. If you stop pedaling, the bike doesn't suddenly lock up. Instead, the rear wheel continues to spin freely, allowing you to coast. The freewheeling unit in a helicopter works similarly. Positioned between the engine and the rotor system, the freewheeling unit acts like a clutch. During normal operation, it transmits power from the engine to spin the rotors. However, if the engine fails, the freewheeling unit automatically disengages. This allows the rotor system to spin freely, driven by the upward flow of air. This free spinning is what allows the pilot to auto-rotate, making a controlled descent and landing. Helicopter flight is all about balance, a delicate interplay between the main rotor and the tail rotor. These two components must work in perfect harmony to ensure stable flight. The main rotor, the most recognizable part of a helicopter, does the heavy lifting, literally. It's the powerhouse that makes vertical flight possible. Its spinning blades generate the lift that gets the helicopter off the ground and keeps it airborne. But there's a catch. This lift comes with a side effect. As the main rotor spins, it creates a twisting force called torque. This torque can cause the helicopter to spin uncontrollably if not managed properly. Imagine trying to turn a heavy wheel. You'd feel a force pushing back against you. This resistance is similar to the torque produced by the main rotor. This is similar to the torque produced by the main rotor. Without a counteracting force, the helicopter would spin in the opposite direction of the rotor. This is where the tail rotor comes in. It plays a crucial role in stabilizing the helicopter. Mounted on the tail boom, the tail rotor acts as a counterbalance to the torque generated by the main rotor. It provides the necessary force to keep the helicopter from spinning. By varying the thrust of the tail rotor, the pilot can control the yaw, or left and right movement of the helicopter, ensuring precise directional control, keeping it pointed in the desired direction. This intricate balance between the main rotor and the tail rotor is what makes controlled helicopter flight possible. Section 4. Countering torque, the anti-torque system. We've established that the main rotor's spin generates torque, a twisting force that would send the helicopter into an uncontrolled spin if left unchecked. This is where the anti-torque system comes into play. It's a critical component that counters the torque, providing stability and control. In most single-rotor helicopters, the anti-torque system is the tail rotor. It provides a lateral thrust in the opposite direction of the main rotor's torque, essentially canceling it out. This allows the pilot to maintain control of the helicopter's heading and prevent unwanted spinning. Without an effective anti-torque system, single-rotor helicopters would be incredibly difficult if not impossible to control. It's this system that allows for stable and predictable flight, making helicopters such versatile machines. Section 5. Fenestron and NOTAR. Alternatives to the tail rotor. While the tail rotor is the most common anti-torque system, it's not the only one. Helicopter engineers have developed innovative alternatives to address the limitations and challenges posed by traditional tail rotors. Some helicopters utilize different approaches to counter torque, each with its own set of advantages and disadvantages. These alternatives are designed to enhance performance, safety, and operational efficiency. Two notable alternatives are the fenestron and NOTAR systems. These systems represent significant advancements in helicopter technology. The fenestron, also known as a shrouded tail rotor, is a fan enclosed within the tail boom. This design is particularly innovative and offers several benefits over traditional tail rotors. This design offers several advantages. The enclosed fan reduces the risk of damage and increases the overall durability of the tail rotor system. It's quieter than a traditional tail rotor, making it ideal for operations in noise-sensitive areas. This is particularly beneficial for helicopters operating in urban environments or near residential areas. It's also safer for ground personnel as the blades are shielded. This reduces the risk of accidents and injuries during ground operations. The NOTAR, or no-tail rotor system, takes a completely different approach. Instead of a traditional tail rotor, it uses a unique method to counteract torque. It uses a fan inside the tail boom to create a high-pressure airflow. This airflow is then directed through slots in the tail boom to produce the necessary anti-torque force. This airflow interacts with the main rotor's downwash, creating a Coanda effect that provides anti-torque force. This innovative approach eliminates the need for an external tail rotor. The NOTAR system is even quieter than the fenestron, and eliminates the risk of anything coming into contact with the tail rotor blades, making it very safe. This makes it an excellent choice for a variety of helicopter operations, particularly in environments where safety and noise reduction are paramount. Section 6. Powering the anti-torque system, different strokes. Powering the anti-torque system, whether it's a tail rotor, fenestron, or NOTAR, requires a dedicated drive system. This system takes power from the main engine and transmits it to the anti-torque system, ensuring it has the necessary power to counteract the main rotor's torque. In most helicopters, the anti-torque drive system consists of a series of shafts and gearboxes. These components transmit power from the main transmission to the tail rotor or other anti-torque system. The system is designed to handle the high speeds and forces involved in rotating the anti-torque device. The complexity of the anti-torque drive system can vary depending on the helicopter's design and the type of anti-torque system used. Regardless of the specific configuration, the anti-torque drive system plays a vital role in ensuring the safe and stable flight of the helicopter. Section 7. Enhance safety and control, the final word. From the freewheeling unit that acts as a safety net during engine failures to the anti-torque system that keeps the helicopter from spinning out of control, these systems are integral to the helicopter's safe operation. The main rotor and tail rotor, or their alternatives like the fenestron and NOTAR, work in harmony to control the helicopter's movement in all three dimensions. These systems, combined with the skill and expertise of the pilot, allow helicopters to perform their unique and valuable missions. Understanding how these systems work provides a deeper appreciation for the complexity and ingenuity of helicopter design. It highlights the delicate balance of forces that must be managed to achieve controlled flight, making helicopters truly remarkable machines.